Welcome back to D3, where wonder and science walk side by side. And we dare to ask the big questions about the universe and our place in it. Today's question is one of the biggest. Can we really terraform Mars? That means turning a cold, dry, alien world into something familiar, something breathable, livable, maybe even lovable. Let's dive deep and explore this ambitious dream, the science, the struggle, and the soul of one of humanity's boldest ideas. Before we break down how, let's talk about why. Terraforming Mars means transforming its hostile surface environment into one that resembles Earth, with breathable air, liquid water, and temperatures that won't freeze you solid in seconds. And the dream is rooted in survival. Backup planet. Earth is fragile. Climate change, nuclear threats, asteroid impacts. Humanity has always faced extinction-level possibilities. Terraforming Mars could be insurance for civilization, scientific curiosity. Mars has fascinated humans for centuries. Terraforming it would be the ultimate scientific challenge, reshaping a planet with knowledge and willpower. Expansion of life. Some thinkers, including Carl Sagan, believed that life, by nature, should spread. Terraforming would mean seeding Earth's life across the stars. But dreams are easy. Execution, that's where the real gravity kicks in. There are multiple proposed methods, all fascinating, all enormously complex. Let's break them down. Release greenhouse gases. One of the leading ideas is to warm Mars up using greenhouse gases. By releasing CO2 trapped in the polar ice caps, soil or rock, we could thicken the atmosphere and raise temperatures, but there's a catch. NASA data shows there isn't enough accessible CO2 to trigger a runaway greenhouse effect, even if we used every bit of it. We'd fall short by a factor of 50. That's like trying to boil a pot of water with a birthday candle. Perfluorocarbon factories. These human-made chemicals are far more potent than CO2. In theory, we could build gigantic PFC factories to pump the Martian skies full of heat-trapping gases. The problem? We'd need millions of these factories running continuously with materials and power systems shipped from Earth or built on Mars. That's a logistics and energy challenge that makes even Elon Musk raise an eyebrow. Orbital mirrors. What if we redirect sunlight to warm the planet? Massive mirrors, kilometers wide, placed in orbit, could beam extra sunlight onto Mars's poles. It's beautiful in theory, but mirror construction and launch would require breakthroughs in material science and space engineering. We're not quite there, yet. Asteroid impacts. A wildcard idea: redirect ammonia-rich asteroids from the outer solar system to crash into Mars. The heat and gases released could warm the planet and introduce nitrogen to build an atmosphere. Of course, that also involves slamming mountain-sized rocks into Mars and hoping for the best. Not the gentlest method: biological seeding. The softest idea: engineer microbes that can survive Mars conditions, photosynthesize, and slowly produce oxygen. It would take centuries, maybe millennia, but this approach mirrors how life transformed Earth's early atmosphere. The challenge? Most microbes die on contact with Martian UV radiation. Even extremophiles struggle in Mars' high radiation, low-pressure environment. Now for the reality check. Terraforming Mars isn't just a science problem, it's a technology, ethics, and economics problem too. Even if we build an atmosphere, Mars doesn't have a global magnetic field to protect it. Solar winds could strip away gases over time, exactly what happened to the planet billions of years ago. Mars has about 38% of Earth's gravity. That could affect atmospheric retention, liquid water stability, and long-term human health. Can humans thrive in low gravity long-term? We don't know. While we've found subsurface ice and seasonal flows, Mars doesn't have the same free-flowing water systems Earth does. Unlocking water at scale would require mining, drilling, or importing. Terraforming would need immense energy, far more than all the power generated on Earth today. We'd need massive solar farms, nuclear reactors, or even space-based energy systems to sustain progress. Even the most optimistic scientists say terraforming would take hundreds to thousands of years and trillions of dollars. It's a marathon of generations. This is where the debate goes beyond science. What if Mars has life? Even microbial life would be precious. Terraforming could destroy evidence of it, or worse, kill something sacred. Do we have a moral responsibility to preserve planets as they are, or a mandate to shape them for life? Critics argue we should prioritize healing our own planet before altering another, but others say we can do both. Earth first doesn't mean Mars never. We may not terraform Mars anytime soon, but we will colonize parts of it. Pressurized domes, underground lava tubes, and self-sustaining greenhouses are already being designed. Missions by NASA, SpaceX, and international agencies are paving the path. We may begin with habitats, then expand to larger, controlled biospheres. Terraforming may not be a single act. It may be a long conversation with the land, the air, and time itself. Terraforming Mars may be science fiction today, but it inspires real innovation, real questions, and real hope. The path will be long, the challenges are immense. But every rover, every launch, every discovery brings us one step closer to understanding not just Mars, but ourselves. So hit that subscribe button and help us reach 3K by June, because we're telling the biggest stories the universe has to offer, one orbit at a time, and always keep looking up.